So compound is a pure substance made up of two or more elements combined in a fixed proportion by mass. Fine. So here what happens, it has some characteristics. Okay, the compounds. It is homogeneous. It is always same. If you take water for example, the molecular formula of water is H2O. So here two atoms of hydrogen and one atom of oxygen is used. So this is same. If you take a glass of water, even the first drop or the last drop will have the same combination. It is all, the particles of the compound is always of the same kind, right? It has definite set of properties. So after the elements combine to form compounds, they have their own set of properties. If we talk about element here, the elements hydrogen and oxygen is present in this compound, where you know hydrogen is a gas, oxygen is also a gas in normal temperature and pressure, but when they combine to form water, it is a liquid. So therefore, water as a compound has its own set of properties and does not retain the properties of the constituent element. Now let us learn how to write the molecular formula of any compound. Okay, if you know the symbol and valency. Suppose I need to write the molecular formula of sodium sulfate. Okay, now this method that I am using to write the molecular formula is called criss-cross method. So which method am I using? Criss-cross method. Okay, so in this method, first step, what is done? You just have to write the symbol of both. This you need to learn. Okay, so sodium we know is Na, sulfate is SO4. We also need to know the valency. So the valency of sodium is 1. The valency of sulfate is 2. Okay, here please notice the electropositive element is always written first, the negative is behind it. Okay, so now the next step, second step, we will criss-cross their valency. For that again we will write their symbol as it is. Okay, so its valency was 2. As a superscript we have written, this will be going to this criss-cross. So the valency of sulfate will be coming to Na, and where will we write? As a subscript down. Okay, the valency of Na is 1. Now this will go to the sulfate ion, and this will again be written as subscript. But as this radical is made up of two elements, it is a compound radical, so we will put a bracket before we write the number. Fine. Now what is the final step? Third step. Now what we do is we write it a little closer, and if it is 1, then we need not write it. Fine. No number means 1. So we will just write SO4. Fine. Clear? Now I will just tell you one thing. By this molecular formula, suppose you are given this molecular formula, you can also tell the valency by back calculation. Okay, so by this formula you can also tell the valency of the component elements. Okay, suppose in your examination you forgotten a certain element's valency, but the salt is used, that element's salt is used in the question paper. So how can you find out the valency from it? So what you do, you just look at the chemical formula there. Okay, here suppose I have forgotten the valency of sulfate. What will I do? So here Na2SO4. I'll quickly think. The 2 crisscross. The 2 has gone to Na, that means the valency of sulfate is 2. Don't forget that crisscross is must. Right. Now this 4, please do not get confused. This 4 is not part of the valency or interchange of valencies. This is part of its symbol as a radical. Fine. So let's do one more example. Suppose I take potassium carbonate. So I'm not writing the steps, I can do it now. Okay, K carbonate CO3, K valency plus 1, valency of carbonate minus 2. I'll crisscross and then K will get 2, CO3 will get the 1. So this is my final answer. Another one, aluminium, say nitrate. Okay, aluminium Al, nitrate NO3. Valency of aluminium 3, nitrate minus 1. Crisscross. Al will get 1, so need not write. NO3 will get the 3, but as it is a compound radical, I will put brackets and write 3. I will do a special case where both have the same valency, like calcium carbonate. Here what happens? Calcium valency is plus 2, carbonate's valency is also 2. So after crisscrossing, what happens? Calcium gets 2 of carbonate, carbonate gets 2 of calcium. But as they are the same numbers, it gets cancelled and the final molecular formula will be CaCO3. Now this is also a very important thing that you know how to name a compound. So there are different cases where how we need to apply our knowledge to name it. Like in the first go, if we have a metal and a non-metal. In a compound, one metal and one non-metal. Then how are they named? Okay, so they are named, that is the metal is written first, followed by the non-metal, and the suffix "ide" is added to the non-metal. Like we take metal Na, non-metal chlorine. So how will we name it? First we'll write the name of the metal. The name of the metal is sodium. And name of the non-metal is chlorine. But the suffix will be "ide." So the name becomes chloride. So what we need to remember? The suffix is "ide." So this is how we can name if a metal and a non-metal is present in a compound. Second case, when two non-metals are there. When both are non-metals in a compound, then the prefix tri or tetra or penta is added as the case may be. Like for PCl3. PCl3, P means phosphorus, Cl means chlorine. Both are non-metals. Here you will not write chloride. So what we will write? P we will write as it is, phosphorus. Okay, so before we write chloride, we need to add the number that is written. 3 means tri. So phosphorus trichloride. If it was PCl5 as phosphorus has variable valency, so it will become phosphorus pentachloride. Okay. Now the next case, when two elements and oxygen is there, then how shall we name it? Okay, like sodium NaClO. Okay, so here the third case, Let me rub this. Two elements and oxygen. Two elements and oxygen. When such a compound is there, the name of the compound depends on the number of oxygen atoms present in the compound. We'll have to consider the number of oxygen atoms in the compound. The prefix means before it. Hypo is used if the number of oxygen atom is less than 2. Okay, for suppose I take NaClO. Example, NaClO. So the prefix pre means before, hypo when oxygen less than 2. So here first we'll write the name of the metal, sodium, and then what will we use? Hypochlorite. Hypochlorite. Done. Now if we get more than 2 oxygen atoms, then the suffix ite Now if the number of oxygen atoms is equal to 2, then what happens? Like for example, so NaClO2. How will we name it? Here only the suffix ite is used. In this case, only suffix ite is used. So sodium chloride. Hypo will be used only when it is less than 2. If 2, straight away chloride. Fine. The next case. Now what will happen if the number of oxygen atom is 3? How do we name it? Okay. So let's see NaClO3. Here oxygen atoms are 3. Then what we do is we use the suffix ate. We use the suffix ate. So how will we name it? Sodium chlorate. Done. Now next, if the number of oxygen is more than 3, then how do we name it? Then what is done? The prefix per is used. Okay. Here oxygen is more than 3. Then what is done? Like for NaClO4. NaClO4. So how will we name it? We will use here prefix. Prefix per. Prefix per is used when the number of oxygen atom is more than 3. So what does the name stand here? Sodium perchlorate. Sodium perchlorate. Okay, so this is how the compounds are named when when two elements and oxygen are there. So now naming of acids. When we are naming binary acids, that is where no oxygen is there. Like for example HCl. Then what we do is we take the prefix hydro. We use the prefix hydro. So here what is the acid? Hydrochloric acid. Fine. So now another example we can do is HF. How, what will the name be? Hydrofluoric acid. Now the next case, that is in polyatomic acids. For example, H2SO4. So here what is done? The main non-metal that is present is taken into consideration, and the acid is named. Hydro is not used. Hydro is not used. So the name is based on the non-metal, that is sulfuric acid. If I talk about HNO3, nitric acid. Okay. So now some non-metals make various kinds of acids, showing difference in the amount of oxygen present in it. Okay, so the lowest, or the acid which the compound which does not have oxygen in it, is given the suffix ide. IDE. So this is named hydrogen sulfide. Okay. Next, the next in line oxygen comparatively is lesser. Okay. So this is named sulfurous acid. For the lesser oxygen, suffix us is used. Okay. If the oxygen is more, then the acid is named as sulfuric acid. The suffix ic is used. So while we were doing the naming of acids, you must have realized what acids are. Acids have hydrogen as the only electropositive radical. Okay, it is a compound which has hydrogen as the only electropositive element.